effective focal length for a different combination of lenses. Suppose we have two lenses. Say we take the example of convex lens. It may be replaced by concave also. The two lenses. The effective focal length of lens when it is combined or when it is cut in transverse, when it is cut along the principal axis, it changes. So the light is coming, this is the separation. If the optical lens is separated by a distance d, from each other, and previously we have seen when the two lenses are kept in contact, we have seen the effective focal length. Now we are going to see when the two lenses are separated by a distance d. What about the focal length? Then the effective focal length. Effective focal length of this combination is given by 1 by effective focal length of the combination is equal to, this is lens 1, this is lens 2, having a focal length 1, focal length 2. So both are positive, it does not make any difference for the calculation, but if you are keeping a concave here, the equation changes. Now here we will not put any sign convention. 1 by f1 focal of the first lens, 1 by focal length of the second lens minus the distance d divided by focal length of the first lens into focal length of second lens. This is equation, we can call it as a equation 1. If d is equal to 0, it means the distance between these two lenses is equal to 0, both are in contact, this becomes 0, this will become normal. This portion is equal to focal 1 by Fe of the combination when both are in contact. Now power also we can write, since we know power is equal to 1 by focal length, so 1 by Fe is equal to effective power of this combination is equal to focal power of the lens 1 plus power of the lens 2 minus 1 by f1 minus d into 1 by f1 is p1, 1 by f2 is equal to p2. So this is in the case of combination of lenses separated by a distance d. As usual, you know, the magnification is equal to height of image by height of object, which is equal to V image distance by object distance. Here we have to put the sign convention in this equation, whether if it is coming minus, the magnification is minus, that it is convex. If this is coming positive, this is also positive, this is also positive, this will be coming positive. In that case, the magnification done is by the concave lens. So if rays are, if rays incident on the first lens and emerge out, coming out, it comes out, incident on the first lens and emerge out parallel with principal axis from the second lens. That is, the rays incident parallel with the principal axis, the rays are incident parallel with the first lens, and it is also emerges out parallel from the second lens. So we can take The example, it may be concave or convex. We can take this example like this. This is the lens. It may be concave, convex. It may be also concave and convex. Now let us not see which is convex, which is concave. We will see in the special case. The rays are parallel, incident on the first lens, and emerges out parallel from the second lens. In that case, the effective focal length of this combination is equal to infinity only for this combination. When rays are incident on the first lens parallel and emerges out from the second lens also parallel, in that case this combination's effective focal length is infinity. In this case, from this equation we can see 1 by Fe is equal to 1 by F1 plus 1 by F2 minus D by F1 into F2. Since 1 by F is it means 1 by Fe will be equal to 0. So 1 by infinity is equal to 0. So this will become 0 is equal to 1 by F1 plus 1 by F2 minus D by F1 F2. F1 F2. This we can write it as. So this we can take one side, this we can take other side. D by F1 F2 is equal to 1 by F1 plus 1 by F2, or D by F1 into F2 is equal to, if cross multiply, this will come F1 plus F2 by F1 plus F2. F1 into F2. This and this cancels, so D is equal to F1 plus F2. So now, if both the lenses are convex, that is F1 and F2 both are positive. In this case, we can write D is equal to F1 plus F2, or D is equal to, take the general equation, we have derived the equation for general lens. It may be concave or convex. We have not specifically mentioned whether it's convex or concave. So D is equal to F1 plus, both are positive, F1 plus F2. So it's equal to F1 plus F2. The distance of separation is equal to sum of this focal length. This is case 1. Case 2. If second lens is concave, the second lens is concave. If the second lens is concave, in this case, focal length of the first lens, since it is convex, positive, and focal length of the second lens is negative because it is concave, negative. First lens is as usual, first lens is convex. In that case, effective focal length, the distance of separation is equal to F1 plus minus of F2. This is D is equal to F1 minus F2. The distance of separation is equal to the difference of focal length of first lens minus focal length of second lens. How it will come? Suppose if we take one lens is convex, another lens is concave. So the rays are incident parallel to the principal axis. These rays are incident parallel to the principal axis. Now we have taken this as convex, this as concave. So how it will emerge parallel out? Let us see. It will converge like this. This ray will go and converge like this. So this is a focus. So after converging, it means this is a diverging lens. It means any rays appears to go from the any rays appears to go from the any ray coming parallel to the lens will either pass through the focal length, focus, or it will appear to pass from the focus. So it means it will appear to pass from the, after refraction to this one, it will go parallel to this, because it comes through the focal, if anything coming from focal length, it will go parallel to the principal axis. This is the combination. Incident ray is also parallel, and the emergent ray from the first and second ray, emerging also parallel, incident also parallel. This is the case of convex, combination of convex and concave lens. In this case, for both are convex. If both are convex, the distance of separation is equal to f1 plus f2. If one is convex, another is concave, this distance, the distance of separation is equal to difference of the focal lengths. We take a lens, and if it is cut into two equal portions, that is a lens, this is a lens having a focal length f is cut into two equal portions. If it is cut into two equal portions, like this, if it is cut like this, plus one more this one, this one. In this case, this portion, this is first lens, second lens, both are part of this lens. It will have a focal length of 2f. This will also have a focal length of 2f. What is the effective focal length when both are combined together with no distance apart in contact? So the effective focal length should be f. That is 1 by effective focal length of these two combination is equal to 1 by first focal length is 2f plus 1 by 2f, and d is equal to 0 if both are kept in contact, is equal to 2 into 1 by 2f is equal to 1 by f. 1 by f. In this case, the effective focal length is equal to f. That is, when both are combined, this is the effective focal length. When one portion, this is C1, this is 2. Another portion, suppose if a lens, half the lens and another half lens, both are having focal length f, is made up of two different material. So one half is made up of some other material having refractive index mu1, another one is refractive index mu2. It will have only one focal length. It will have only one focal length. This is the focal length distance. It does not make difference. One portion is filled, one portion is some media, another portion is another one media. It does not make any difference. Another example, third, if a portion of the lens is filled, upper portion is filled with some media and lower portion with another media, another refractive media, another. So this is, in this case, this will have a refractive index of mu1, this will have a refractive index of mu2. Both will have, since refractive index same, it is a converging lens. This will converge here and this will converge here. Both are having same action, but their focus are different. For lens 1, this is lens 1, this is a lens 2, and the image 1, this is image 2. It means if the lens are made up of two materials, it will have two focal length and two images. If there are having three media, 1, 2, 3, and it will have three focal lengths and 3 media. And suppose if it is having 3 media like this, we can see one, another one, this is one material, this is another material, this is another material. In that case, it will have focal length 1, this will have focal length 2, depending upon the refractive index. So this is f1, this is f2, this is f3. In that case, because its refractive index of mu3, its refractive index is mu2, its refractive index is mu1. In that case, this lens, single lens, will have 3 focus and hence 3 images. Think that if it is filled in the first top, in this way it is filled, it will have 3 focal, but this way one portion and equal of portion is different material. The focal length always will remain same. The effective focal length will always remain same. And fourth, the intensity of the light ray. It means what is intensity? Intensity is equal to aperture area, proportional to aperture area. It means what? Area. Area means what? How much area the incident ray is falling on the lens is proportional to area. If 1/4, this is 1/4 of the lens, this is another 1/4 of the lens, convex lens. 1/4 lens is exposed to light rays. 1/4 is exposed to light ray. It will produce the same image, but the intensity of the image produced, intensity of image produced will be 1/4 of the intensity of image produced by full lens. That is, if you are giving 1/4 of the lens, the light is falling on it, parallel to it, it will produce image here, but the intensity will be reduced to 1/4 of the intensity when it is passing through the full lens. When it is passing through the full lens, the only thing you have to remember in this JEE and NEET questions are coming, what about the intensity? What about the intensity when the lens is cut into pieces, cut into some sections of the lenses are cut? It means intensity is equal to aperture square. In that case, you can take it intensity is equal to aperture, proportional to aperture. It means how much portion is bleeding, that much portion of the intensity will only produce. If the full lens is producing some intensity, it will produce 1/4 of the intensity, but the image will be produced the same as produced by the single lens. If the lens, if the convex lens is cut like this, it is cut like this. See, one portion we can take it this way, another portion we can take it this way. It is cut, and this combination is put in different style. That is, we take first lens and we take one portion. This is focal length is f. Its focal length will be also s. Its focal length will be also f. Only it is, if it is cut in transverse section, if it is cut, it will be 2f 2f, and we keep both the combination like this. So we are not giving any distance between them. They are kept in contact with each other. This will be having f, and this will be having the effective focal length 1 by f. Effective is equal to this 1 by f plus 1 by f is equal to 2 into 1 by f. So effective focal length is equal to f by 2. F by 2. In this case, the effective focal length, when these two pieces are joined in this fashion, the effective focal length of this will be focal length of the original lens divided by 2. If this piece is kept like this, this principal axis one, we kept it like this, another one we keep it like this, in reverse way. Here both are kept in the same fashion. This is kept here and this is kept here. In that case, when both are added, the effective focal length is equal to f by 2. When it is one is kept like this, another is kept in a reverse order, both are having a focal length of f and f2. This effective focal length of this combination of the two pieces is equal to 1 by f plus, what about this one? Because this will behave like a convex lens, because this is coming like this. So like this, it means this will behave as a concave lens. In that case, 1 by f1 by 1 by f2, since d is equal to 0, is equal to 1 by f1 plus 1 by, for convex this is focal length is negative, for this focal length is positive, minus f2 is equal to 1 by f1 minus 1 by f2, since f1 is equal to f2 is equal to f, because this also having f, 1 is f, 2 is also f, 1, 2. In that case, 1 by f minus 1 by f is equal to 0. It means 1 by fe is equal to 0, or fe is equal to 1 by 0, which is equal to infinity. If the same lens kept in this combination, the effective focal length comes out to be infinity. It means if you are keeping this length in this fashion, it will behave like a plane mirror. It will behave like plane mirror whose focal length is equal to infinity.